In this video lesson on energy, we're going to be focusing on potential and kinetic energy, and then energy transformations. In your last video, you learned that energy is always transforming from one form of energy into another. Now we're going to give several examples on that. So remember that energy is the ability to do work. And to do work, a force is put on something and it has to move in the direction of that force. If it doesn't move, work wasn't done. Energy can be found in a number of different forms. It can be chemical, electrical, heat, light, mechanical. When you hear mechanical energy, I want you to think moving, and nuclear. Energy is what makes everything happen and can be divided into two types. We have the first one, which is stored energy. That is potential energy. It is the energy of position because the higher something is, the more stored or potential energy it has. Moving energy is called kinetic energy. When you see that word kinetic, I want you to think motion. Something is moving. Now, you don't either just have potential or kinetic. For example, when this girl has this ball up here and she drops it, she has the most potential when she's just holding it here because that's stored energy. But as she lets it go, the potential energy is decreasing while the kinetic energy is increasing until right before it hits the ground. That has the most kinetic and the least potential. Then it hits the ground and stops. Now it has potential energy again. To demonstrate the two different types of energy, potential and kinetic, try this activity here. Put the pencil at the edge of your desk and push it off onto the floor. The moving pencil uses kinetic energy. Now, pick the pencil up and put it back on the desk. You used your own energy to lift and move the pencil. Moving it higher than the floor adds potential energy. Then as it rests on the desk, the pencil has that potential energy. The higher it is, the further it could fall. That means the pencil is going to have more potential energy. Kinetic energy is the energy of motion, and it depends on two things, mass and speed. Okay, we haven't learned about speed yet, but we will learn how to figure out what speed is. But for right now, I need you to know that kinetic energy is mass and speed. So kinetic energy equals mass times v. V is velocity, which is another way of saying speed. It just adds direction. Squared divided by 2. So let's take a look at this cute little sports car and this truck. If this car and truck were going 55 miles per hour, so their speed is the same, which would have the highest kinetic energy? So if kinetic energy is mass times speed and the speed is the same in both, then what are we going to look at? If you said we're going to look at the mass, you're absolutely right. So if you chose the truck because it has a higher mass, that's correct. The truck has more kinetic energy. Okay, let's look at these pendulums. If I take a ball and I raise it up to position A and it stops, now I have the highest potential energy. As I let it go, the kinetic energy is increasing as the potential energy is decreasing until I hit D, where I have the highest kinetic energy. It hasn't hit the floor, it's still moving, so that's the highest kinetic energy. Now, as it begins to go back up, it starts to lose that kinetic energy and gain potential until it hits G again, where it stops for that split second and it has the most potential energy. Okay, potential energy is stored energy. And as we showed you before, it depends on the position. The higher you go, the more potential or stored energy you have. So if you lift an object, you're doing work on it because you're applying a force and it's moving in the direction of that force. You use a force that's against the force of gravity. So you are transferring that energy to the object, and then you give that object, as it goes higher and higher, potential energy. Now, potential energy is based on weight and height. And again, we could also talk about mass and height. Now, look at this guy with the bow and arrow. As he stretches that bow out, the string out, he gains potential energy. Because here's where the string started, and then he pulled it back. Now he's got potential energy. When he lets it go, now the arrow is moving, and he gains kinetic energy. Let's look at this staircase here with the balls on it. Which ball has the most potential energy? Why? What do you need to assume about the matter of the balls? If you said weight or mass and height, you're absolutely right. So take a look at the different balls here. Which one has the most potential energy? If you said C, you're absolutely right. It has the most weight or mass, and it's at the top of the stairs. So weight is the amount of force that you have to use on an object to lift it, and height is a distance. So potential energy is equal to the amount of work done on that object to lift it a certain height. So here's the distance, the 30 kilogram mass rose above the ground. So it's the weight times the height, or the mass times the height. Or we could think of potential energy as being equal to the work that would be done by that object if it were dropped from a certain height. So if we think of mass as the amount of matter in this ball here, and the height, what is the length above the Earth's surface? So the work that's being done is against gravity, because gravity's pulling down. So if you lift this ball up against gravity, the higher you go, the more height there is, the more stored energy or potential energy the ball has. Okay, so let's look at this hill with the ball at the top of the hill. The ball at the top of the hill has a great amount of potential energy and zero kinetic because it's just sitting there. It has no motion whatsoever. So it has the highest potential energy. As it starts to roll down the hill, it's going to lose potential and gain kinetic. So right here, it's got both kinetic and potential energy. Then it keeps rolling here. When it reaches about here, it's got the most kinetic energy. And then when it keeps rolling and comes to a stop, now it has the most potential and no kinetic energy. Because it's not moving. It has stopped. Okay, let's look at this guy that's on top of the building and he's holding a ball. As he's just holding it there, it's got 100 potential energy and 0 kinetic because he's just holding it. Now, as he drops it, you can see the potential energy starts to go down because it went from 100 to 80. Now, look what's happening to the kinetic. It's going from 0 to 20. So the kinetic energy is increasing and the potential energy is decreasing. And as the ball keeps going down, the potential energy went from 80 to 40. It's still decreasing, but look at the kinetic energy. It moved from 20 to 60, so it's getting even higher until right before that ball hits the ground, it's only got 1 potential energy left, and 99% of it, because it's moving, is kinetic energy. Now, once it hits the ground and it stops moving, now it's got potential energy again and no kinetic. Which one has the highest potential energy and which one has the highest kinetic energy? And believe it or not, this truck is going faster than the airplane. So remember what we said about potential and kinetic energy having to do with mass and speed and position. If you said that the airplane has the highest potential energy, I would agree with you, because it looks to me like the airplane and the truck have about equal mass. But remember that potential has to do with that mass or weight and position or height, and it's much higher. If you said that the truck has the highest kinetic energy, I would agree with you, because to me, since I told you that the truck is going much faster, it has a higher speed, and I think the masses are about the same. So I would say the truck has the highest kinetic and the airplane has the highest potential. This video was getting a little long, so I'm putting the energy transformations in a third video. Make sure that you're taking your closed notes while you're watching, or go into Nearpod and take them from there. Thank you.